Okay, so get this. We're diving into 4D printing today.
Yeah.
4D printing.
Yeah.
The thing that just sounds like straight up science fiction.
Right.
Turns out it's more science fact than fiction. And honestly,
Yeah.
I've got a stack of research here.
Uh-huh.
And even I'm a little intimidated by just how much there is to cover.
I bet.
But lucky for us, we've got our resident expert in emerging tech here with us to help break it all down.
It's a pleasure to be here. I think the best way to think about it is that we're adding the element of time to 3D printing.
Okay.
Objects can change shape, they can assemble themselves over time, they can even repair themselves.
Self-repair.
Yeah, it's all driven by advances in what we call smart materials, They can respond to things like heat or light or even water.
So time-traveling objects aside, I get that 3D printing was a big deal.
Yeah.
But where does it fall short?
Yeah. So one of the things that stood out to me in the Future Bridge report is that while 3D printing was revolutionary for design and prototyping,
Right.
It's not always practical for mass production.
Okay.
4D printing kind of addresses that by introducing flexibility, objects that can adapt and change over time, change in response to their environment.
Adapt and change.
Yeah, so think about self-folding packaging that optimizes space during shipping, or wind turbines that adjust their shape to capture different wind conditions.
Wow. Okay, that's
where 4D printing really shines.
Yeah, adaptable, efficient, sounds pretty complex.
Right.
What are the building blocks of 4D printing?
So it all starts with those smart materials.
Okay.
One example is shape memory polymers. Think of them like plastics with a memory.
Okay.
You can deform them, but then they'll remember their original shape and go back to it when they're triggered, by a change in temperature or something like that.
Uh-huh.
And then you have hydrogels, those super absorbent polymers. I mean, they're used in everything from diapers to contact lenses.
Wow.
But in the world of 4D printing, we're talking about hydrogels that can swell or shrink
Oh, wow.
to change the shape of an object on demand.
So we're talking about materials that are almost like alive.
Yeah.
They react
Right.
and they change. What are some of the more mind-bending examples?
Oh, there are some really wild ones. So Future Bridge highlights a project from BMW and MIT where they developed a material that inflates with these targeted air pulses, like some kind of futuristic pneumatic system.
Oh, wow.
And then you have researchers at MIT Self-Assembly Lab who printed a chain that spells out MIT.
What?
When you put it in water.
A self-sculling chain. I don't know if that's brilliant or just shows that scientists have way too much time on their hands.
Right.
But let's be real. Designing these objects can't be as simple as, drawing something in a 3D modeling program.
Right. It's not as simple as that. The Wikipedia article talks about how you're not just designing a shape, you're predicting and programming how that object will transform over time.
Yeah.
This involves understanding the properties of the smart material and how they react to the different stimuli. It's like embedding instructions into the object itself, and it's not just shapes. The properties of the material, like the color or texture, can also be designed to change.
So less about design, more about choreography.
Yeah.
Planning out movements.
That's a great way to put it. And to do that, you need really sophisticated software, a deep understanding of material science. It's a whole new level of complexity compared to traditional design. Programmable matter.
Wow.
It's about designing the material to behave in specific ways.
Okay, so we've got these shape-shifting materials, incredibly complex designs, and now we need a printer that can actually handle all of this.
Yes, exactly. So the printing technology, it builds on existing 3D printing methods like fused deposition modeling,
Okay.
where layers of material are built up, but it requires much greater precision and control. Another common technique is stereolithography.
Stereolithography.
Yeah, it uses lasers to cure a liquid resin layer by layer.
Hold on. For those of us who aren't material scientists, can we break that down a bit?
Sure. So imagine a vat of liquid plastic. And this liquid hardens when it's exposed to a very specific wavelength of light.
Okay.
And a laser that's controlled by the software traces the shape of each layer onto the surface of the liquid, curing it into a solid.
Okay.
And then the layers build up, the 3D object starts to take shape.
Okay.
And in 4D printing, this process can be even more complex because you're working with multiple materials.
Right.
Each with its own properties and curing requirements.
So it's like a high-tech version of those liquid plastic kits?
Uh-huh.
Like we had as kids.
Exactly.
Where you pour the goop in the mold and it solidifies.
Yeah. Except with lasers and robots and self-folding chains.
Right. Instead of simple molds, we're talking about laser movements that are creating objects that are designed to transform and adapt over time.
Yeah.
Okay, my mind is officially blown. So let's get to the good stuff. What can we actually do with this technology? What are some of the applications that have people so excited?
That's where it gets really interesting.
Yeah.
The possibilities are almost limitless. The medical field is particularly exciting. Researchers are exploring things like self-adjusting stents that expand with body heat to keep blood vessels open, or bioprinted scaffolds that can be used as a framework for new tissue growth.
Now you're speaking my language. Self-adjusting stents, bioprinted organs. That's the future of healthcare.
Right.
Right there. So let's dive into the medical applications.
Sure.
I'm curious, how does this actually work inside the body?
Well, one of the most promising areas is targeted drug delivery. Imagine tiny 4D printed devices that can deliver medication directly to a specific spot in the body,
Okay.
releasing it over time or in response to a trigger, like a change in pH.
Okay, that's way beyond just taking a pill. It's like having a micropharmacy inside you.
Right.
What kind of research is being done there?
Well, one example that caught my eye was the research at Johns Hopkins, where they've developed these micro devices called Theragrippers.
Theragrippers?
Yeah, these things are incredibly small, like specks of dust, and they're made of a shape-changing material that's coated in paraffin wax. So when the Theragripper reaches the target area, the heat from the body melts the wax, and it clings on and releases the drug.
It's like a heat-seeking missile from medicine.
Yeah, kinda.
It's both impressive and a little bit creepy.
Right.
Are there any other examples of 4D printing being used this way?
Yeah, absolutely. The University of Michigan has been doing some really interesting work with 4D printing to create a life-saving implant for babies with a condition called tracheobronchomalacia.
Try saying that 3 times fast.
Right. It's a condition where the airway collapses.
Okay.
So the implant expands as the baby grows to support the airway, and then it eventually dissolves so you don't need further surgery.
So 4D printing helps the baby breathe.
Yeah, exactly.
Wow. That's personalized medicine to a whole new level.
Right.
What about those self-adjusting stents we were talking about? How far along is that research?
So stents are a perfect example of where 4D printing can make a real difference. With the traditional stents, there's a risk of them shifting or not fitting, right? But imagine a stent that can adjust its diameter to respond to the body temp or the blood flow.
Oh.
So it's a perfect fit, and it reduces the risk of complications.
Yeah.
That's what researchers are working toward, and the early results look good.
So instead of like a static device, it's like a dynamic, responsive system adapting to the body's needs.
Exactly.
That makes a lot of sense.
Yeah.
But healthcare isn't the only thing being revolutionized by 4D printing, is it?
Oh, no, not even close. Another area that's really taking off is soft robotics.
Okay.
These are robots made entirely of flexible materials. They can interact with their environment in ways that regular robots can't. Delicate tasks like surgery or search and rescue or even handling fragile objects.
Okay, so forget the clunky metal robots of the past. We're talking robots that are, well, soft.
Right.
But wouldn't that mean they're not as strong or durable?
There are trade-offs, for sure.
Okay.
But what you lose in strength, you gain in flexibility and adaptability.
Right.
A soft robot can squeeze through small spaces,
Ooh.
conform to irregular shapes, and interact with humans more safely.
Yeah, that's a good point.
Researchers at CU Boulder have developed a 4D printed robotic hand that can grasp and manipulate objects with amazing dexterity.
Okay, that's impressive. A robot hand that can grasp. I'm starting to see why people are so excited about this technology. What about clothes? Any progress on those self-healing wardrobes we were talking about?
Yeah, the textile industry is paying attention. Imagine clothes that can adapt to temperature and moisture.
Oh.
Keep you cool in the summer, warm in the winter.
Right.
The military is already testing uniforms that change camouflage depending on the environment. 4D printed materials that respond to light.
Camouflage that adapts on the fly. Sounds like something straight out of a spy movie.
I know, right?
But what about applications beyond the military? Could we see this in everyday clothes?
Absolutely. Think about sportswear that adapts to your body's movements,
All right.
providing support and ventilation where you need it.
Right.
Or medical textiles like bandages that can adjust their pressure or release medication.
So it's not just fashion, it's function and performance too.
Right.
That makes a lot of sense. What about space? I'm guessing NASA is all over this technology.
You bet. NASA's exploring 4D printing for a bunch of different applications. One of the most exciting areas is developing lightweight, self-repairing materials for spacecraft.
Okay.
Imagine a spacecraft that can heal itself from like a micrometeorite impact or something.
Self-healing spacecraft. Sounds like something straight out of Star Trek.
Right.
But what about back here on Earth? How could 4D printing be used in things like construction or engineering?
Well, the construction industry is very interested in 4D printing, especially for creating self-healing concrete. So think about roads that can repair their own cracks, bridges that adapt to loads over time. Okay. Automotive. Imagine self-assembling car parts or airbags that anticipate impact.
Okay, you blew my mind again, officially. It seems like 4D printing has the potential to revolutionize pretty much every industry.
It really does.
But with all this talk about transformation and adaptation, it makes me wonder about the safety and reliability of these 4D printed objects.
Yeah.
I mean, can we really trust things that are constantly changing shape?
It's a really important question, and one of the key challenges is ensuring that the transformations are predictable and controlled.
Okay.
It's not just about making something change shape.
Right.
It's about understanding how it'll change and under what conditions and making sure it's safe and it works throughout its whole lifespan.
So it's not just about designing the object itself, it's about designing the transformation.
Exactly.
That makes sense. But wouldn't that make the design process even more challenging?
Yeah, for sure. The design and modeling is super important for predicting how it'll behave over time, making sure it's safe for its intended use. And just like with any new product, rigorous testing is essential before you can think about widespread adoption.
That's reassuring. I don't want my 4D printed house rearranging itself in the middle of the night. But speaking of testing, one thing I'm curious about is the cost of all this. Is 4D printing going to be a technology that's only available to big corporations and research labs? Or could we see a future where it's available to everyday people?
Right now, 4D printing is definitely expensive.
Yeah.
The materials are specialized, the design is complex, the
Yeah.
equipment is sophisticated. But as with any new technology, we can expect to see the costs come down as research advances.
Right.
Production gets more efficient, new materials and techniques.
Okay, so maybe someday we'll have 4D printers in our homes.
Yeah,
Just
right.
like we have 3D printers now.
Exactly.
Opens up a whole world of possibilities. But before we get ahead of ourselves, are there any companies or organizations that are really leading the charge right now in 4D printing? Who should we be paying attention to?
Well, one of the key players is MIT's Self-Assembly Lab.
MIT.
Yeah, led by Skylar Tibbetts. They're doing some really groundbreaking work, pushing the boundaries of what's possible.
Yeah, MIT is definitely a powerhouse when it comes to research. What about the private sector? Who's making waves on the commercial side?
So the companies that make 3D printers are also playing a key role in advancing 4D printing.
Okay.
Companies like Stratasys, 3D Systems, EOS, they're all investing in research and development to create printers that can handle the complexity of 4D printing.
So it's like a collaboration.
Yeah.
Research labs pushing the boundaries and then companies figuring out how to actually make it all work.
Exactly. And I'm guessing there are a bunch of startups popping up too.
Oh, yeah, for sure.
Trying to find their niche.
Yeah, it sounds like a very dynamic and rapidly evolving field.
It is.
So with all this innovation happening, I'm curious to hear what you think about the future of 4D printing. Where is this all headed in the next 5 to 10 years?
Yeah. If I had to gaze into my crystal ball, I'd say we're going to see major advancements in the next decade.
Okay.
We'll see more smart materials available,
Right.
more versatile, accessible for different applications,
Right.
more sophisticated software that can predict and control the transformations,
Okay.
making the design more intuitive and less prone to errors.
So even more mind-blowing applications and designs on the horizon.
Exactly.
I'm ready for it.
Yeah.
What about the cost and accessibility? Do you think 4D printing will become more affordable and widespread?
I think it's inevitable. As the technology matures and production scales up, we can expect to see costs come down. 4D printing will become more accessible to smaller businesses and research institutions and maybe even individuals. You can imagine a world where you could download a design for self-assembling furniture and print it at home.
That's a pretty amazing thought. It'd be great to see it more democratized so that more people can innovate and create. But with all this talk about the future, I want to go back to something you mentioned earlier about responsible development.
Right.
As 4D printing becomes more powerful and pervasive,
Yeah.
what are some of the ethical considerations that we need to be thinking about? What are the downsides?
Yeah, so one of the key concerns is the potential impact on jobs. As 4D printing enables more automation,
Right.
it's important to think about how that will affect workers in traditional manufacturing industries.
Okay.
We need to think about ways to retrain and reskill workers
Right.
so that they can thrive in this new landscape.
That's a crucial point. It's important to make sure that these technological advancements benefit society as a whole
Yeah.
and don't just worsen existing Inequalities?
Exactly.
What other ethical considerations are there?
Well, another one is misuse. As with any powerful technology, there's always a risk that it could be used for things that can cause harm. Imagine 4D printed weapons that could self-assemble or change shape, making them harder to detect.
Yeah, that's scary.
We need to establish clear guidelines and regulations to prevent that.
It seems like these ethical considerations with 4D printing
Yeah.
are similar to those that we've seen with AI
Right.
and genetic engineering. It's a reminder that innovation has to be balanced with responsibility.
Absolutely. We have to be thoughtful about how we use this technology, making sure that we're using it for good,
Right.
not creating unintended consequences.
So to bring this all together,
Yeah.
what are some of the key takeaways?
Okay, so first, 4D printing is more than just 3D printing with a new name.
Right.
It's about adding the dimension of time, using smart materials to make objects that transform and adapt.
Right.
The applications are vast and varied, from self-healing concrete and shape-shifting robots
Wow.
to personalized medical devices and clothing that adapts.
Amazing.
And while 4D printing is still emerging, it has the potential to revolutionize lots of industries and change the way we live and work.
Yeah.
There are challenges, scalability, cost, the need for more sophisticated materials and techniques.
Right.
Ethical considerations are also really important. We need to make sure that 4D printing is used responsibly and benefits society as a whole.
Those are all excellent points. But beyond the technical details
Right.
and potential applications, I think the most important takeaway is this. 4D printing is a reminder that the future isn't something that happens to us.
Yeah.
It's something that we create.
I completely agree. It challenges us to think beyond the limitations of traditional manufacturing and imagine a world where objects are no longer static, but dynamic and responsive.
Exactly. Empowering people to solve problems in new and innovative ways.
Yeah.
And that brings us to our final thought-provoking question for our listeners.
Okay.
If you could create anything using 4D printing, what would it be? What problem would you solve?
Well, that's a good one.
How would you make the world a better place?
Yeah.
Let your imagination run wild and share your ideas with us online using the hashtag 4DDreamBig.
Love it.
We can't wait to see what you all come up with.
Yeah, me too. And remember, even though 4D printing is still early, the possibilities are pretty much limitless.
Well said. And on that note, we've reached the end of our deep dive into the fascinating world of 4D printing.
It's been a really enlightening journey.
I agree. Thanks for joining us on the deep dive. We'll be back soon with another fascinating topic to explore, so be sure to subscribe and stay tuned.
Until next time, keep those minds curious and those imaginations soaring. And it's not just healthcare that's being revolutionized by 4D printing.
Right.
Another area that's really taking off is soft robotics.
Soft robotics, okay.
Yeah, these are robots that are made entirely of flexible, adaptable materials so they can interact with their environment in ways that traditional robots just can't.
Oh, okay, I see.
Yeah.
So they're more like,
They could be used for delicate tasks,
oh,
like surgery or search and rescue operations or even handling fragile objects.
okay, so we're talking about robots that are more like, well, soft.
Yeah.
But wouldn't soft robots have limitations
Yeah.
in terms of like strength and durability?
There are definitely trade-offs.
Yeah.
But what you lose in boot strength, you gain in flexibility and adaptability. A soft robot can squeeze through tight spaces, conform to irregular shapes,
I see.
and interact with humans more safely.
Yeah, that's a good point.
Researchers at the University of Colorado Boulder have actually developed a 4D printed robotic hand that can grasp and manipulate objects
Oh, wow.
with incredible dexterity.
Okay, that's pretty impressive. A robot hand that can grasp. I'm starting to see why people are so excited about this technology. What about clothes? Any progress on those self-healing wardrobes we talked about?
The textile industry is definitely paying attention to 4D printing.
Okay.
Imagine clothes that can adapt to temperature or moisture, keeping you cool in the summer and warm in the winter.
Oh, wow, yeah.
The military is already testing uniforms that change camouflage based on the environment thanks to 4D printed materials that respond to light.
Camouflage that adapts on the fly. That sounds like something straight out of a spy movie.
I know, right?
But what about applications beyond the military? Could we see everyday clothes with these kinds of features?
Absolutely.
Oh, wow.
Think about sportswear that adapts to your body's movements, providing support and ventilation where you need it most. Or medical textiles like bandages that can adjust their pressure or even release medication as the wound heals.
So it's not just about fashion, it's about functionality and performance, too.
Exactly.
That makes a lot of sense. What about space exploration? I'm guessing NASA is all over this technology.
You bet.
Yeah.
NASA is exploring 4D printing for a wide range of applications. One of the most exciting areas is developing lightweight, self-repairing materials for spacecraft.
Okay.
Imagine a spacecraft that can heal itself from micrometeorite damage.
Self-healing spacecraft. That sounds straight out of Star Trek.
Right.
But what about applications here on Earth? How could 4D printing be used in, say, construction or engineering?
The construction industry is very interested in 4D printing, especially for creating self-healing concrete.
Self-healing concrete.
Yeah, think about roads that can repair their own cracks, or bridges that can adapt to changing loads over time.
Oh, wow.
And in the automotive industry, imagine self-assembling car parts or airbags that anticipate impact based on real-time sensor data.
Okay, my mind is officially blown again. It seems like 4D printing has the potential to revolutionize pretty much every industry we can think of.
It really does.
But with all this talk about transformation and adaptability, it makes me wonder about the safety and reliability of these 4D printed objects.
Yeah.
Can we really trust things that are constantly changing?
That's a really important question, and one of the key challenges with 4D printing is ensuring that the transformations are predictable and controlled.
Right, okay.
It's not just about creating something that changes shape, it's about understanding exactly how it will change under what conditions, and ensuring that it remains safe and functional throughout its lifespan.
So it's not just about designing the object, it's about designing the transformation itself.
Exactly.
That makes a lot of sense. But wouldn't that make the design process even more complex and challenging?
Absolutely. The design and modeling phase is crucial for predicting how the object will behave over time and making sure it's safe for its intended use. And just like with any new product, rigorous testing is absolutely essential before widespread adoption.
Okay, that's reassuring. We don't want our 4D printed houses to start rearranging themselves in the middle of the night. But speaking of testing, one thing I'm curious about is the cost of all of this. Is 4D printing going to be a technology that's only accessible to big corporations and research labs? Or could we see a future where everyday people have access to it?
Right now, 4D printing is definitely on the expensive side. The materials are specialized, the design process is complex, and the printing equipment is sophisticated. But as with any new technology, we can expect to see costs come down over time as research advances, production becomes more efficient, and new materials and techniques are developed.
So maybe someday we'll have 4D printers in our homes just like we have 3D printers now.
Yeah, exactly.
That opens up a whole world of possibilities. But before we get ahead of ourselves, are there any companies or organizations that are really leading the charge in 4D printing today? Who should we be paying attention to?
One of the key players we already mentioned is MIT's self-assembly lab, led by Skylar Tivitz. They're doing some really groundbreaking work, pushing the boundaries of what's possible with 4D printing.
MIT is definitely a powerhouse when it comes to cutting-edge research.
Right.
What about companies in the private sector? Who's making waves in the commercial side of 4D printing?
Well, the companies that develop and manufacture 3D printers are also playing a crucial role in advancing 4D printing technology. Companies like Stratasys, 3D Systems, and EOS are all investing in research and development to create printers that can handle the complexities of 4D printing with multiple materials and intricate transformations.
So it's a collaborative effort, research labs pushing the boundaries of what's possible, and companies figuring out how to make it a reality. And I'm guessing there are probably a lot of startups popping up in this space as well, trying to find their niche.
You're absolutely right. The startup scene is buzzing with innovation in 4D printing. There's Nervous System, a company creating stunning nature-inspired designs using 4D printing. And then there's BioBots, a company developing bioprinting platforms for applications in tissue engineering and regenerative medicine.
It sounds like a very dynamic and rapidly evolving field. So with all of this innovation happening, I'm curious to hear what you think about the future of 4D printing. Where do you see this technology heading in the next 5 to 10 years?
If I had to gaze into my crystal ball, I think we can expect some major advancements in the next decade. We'll likely see a wider range of smart materials become available, making 4D printing more versatile and accessible for different applications. And I think we'll see even more sophisticated design and modeling software that can accurately predict and control those complex transformations, making the design process more intuitive and less prone to errors.
So even more mind-blowing applications and designs on the horizon.
Exactly.
I'm ready for it. But what about the cost and accessibility? Do you think 4D printing will become more affordable and widespread in the near future?
I think it's inevitable as the technology matures and production scales up. We can expect to see costs come down, making 4D printing more accessible to smaller businesses, research institutions, and maybe even individuals. Imagine a world where you can download a design for a self-assembling piece of furniture and print it at home.
Uh, that's a pretty amazing thought. I think it'd
Mhm.
be great to see 4D printing become more democratized, giving more people the power to innovate and create. But with all this talk about the future, I want to circle back to something you mentioned earlier, the importance of responsible development as 4D printing becomes more powerful and pervasive. What are some of the ethical considerations we need to be thinking about? What are the potential downsides that we need to be aware of? Welcome back to the deep dive. So
Sure.
far, we've really gone down the rabbit hole of 4D printing. I mean, we've talked about everything from its origins in 3D printing to how it's going to revolutionize industries like healthcare, construction, and even fashion. I don't know about you, but I'm still trying to wrap my head around the idea of clothes that can change camouflage on the fly.
Yeah, it's remarkable how quickly this technology is evolving, and to think we've only just begun to scratch the surface of what's possible.
It's a lot to take in. So for our listeners who might be feeling a little overwhelmed, let's try to distill all of this information into some key takeaways. What are the most important things people should know about 4D printing?
Well, first and foremost, it's essential to remember that 4D printing is more than just creating cool shapes. We're not just talking about 3D printing with a fancy new name. It's about adding that dimension of time, using these incredible smart materials to create objects that can transform, adapt, and respond to their environment.
So the objects have like a life of their own, changing and evolving over time. But if you had to break it down, what are the core components of this technology? What makes it all work?
4D printing relies on three key elements. First, you have the smart materials, things like shape memory polymers and hydrogels that react to stimuli like heat, light, or moisture. These materials are the building blocks of 4D printed objects, giving them the ability to change shape and property.
So the materials themselves are almost like tiny machines, programmed to respond in specific ways. What's the second element?
The second element is the design and modeling process. This is where things get really complex because you're not just designing a static object, you're designing the transformation itself. You have to think about how the material will behave over time, how it will respond to different stimuli, and how those transformations will achieve the desired function. It requires sophisticated software and a deep understanding of both material science and engineering principles.
It's almost like choreographing a dance, but instead of dancers, you're working with molecules and materials. Okay, so we've got the materials, the design. What's the third piece of the puzzle?
The third element is, of course, the printing technology itself. While 4D printing builds on existing 3D printing methods, it requires even greater precision and control. We're talking about printers that can handle multiple materials, create incredibly intricate structures, and deposit materials with micron-level accuracy.
So it's not just your average desktop 3D printer. We're talking about some serious high-tech equipment.
Absolutely. And as the technology continues to evolve, we can expect to see even more sophisticated printers capable of creating even more complex and functional 4D printed objects.
Now, we've touched on a lot of potential applications, but it's clear that 4D printing is still an emerging technology. Where do you see the biggest opportunities for growth and development in the coming years?
I think one of the most exciting areas is the development of new smart materials with even more impressive properties. We're talking about materials that can respond to a wider range of stimuli, materials that can change color or texture, materials that are even stronger and more durable. Imagine a world where we can print objects that can heal themselves, adapt to changing conditions, or even generate energy.
It's like the line between science fiction and reality is starting to blur. But with all this talk about the potential of 4D printing, it's important to remember that there are also challenges that need to be addressed. What are some of the hurdles that researchers and companies are still working to overcome?
Well, one of the biggest challenges is scalability. Right now, 4D printing is mostly confined to research labs and specialized manufacturing facilities. If we want to see this technology truly take off, we need to figure out how to make it more affordable and accessible for a wider range of applications. That means developing new materials that are easier and cheaper to produce, designing printers that are more efficient and user-friendly, and streamlining the design process so that it's not so time-consuming and complex.
So basically, we need to make it faster, cheaper, and easier. Makes sense. But beyond the technical challenges, there are also those ethical considerations we touched on earlier. As 4D printing becomes more powerful and pervasive, what are some of the things we need to be mindful of?
One of the key concerns is the potential impact on jobs. As 4D printing enables more automated and self-assembling processes, it's important to think about how that will affect workers in traditional manufacturing industries. We need to be proactive in thinking about ways to retrain and reskill workers so they can thrive in this new technological landscape.
That's a crucial point. It's important to ensure that technological advancements benefit society as a whole rather than exacerbating existing inequalities. What other ethical considerations should we be keeping in mind as this technology continues to evolve?
Another important consideration is the potential for misuse. As with any powerful technology, there's always the risk that it could be used for harmful purposes. Imagine 4D printed weapons that can self-assemble or change their shape, making them harder to detect and control. It's crucial that we establish clear ethical guidelines and regulations to prevent the development of such applications.
It seems like the ethical considerations we're facing with 4D printing mirrored those we've seen with other powerful technologies like AI and genetic engineering. It's a reminder that innovation needs to be balanced with a sense of responsibility.
Absolutely. We need to be thoughtful about how we develop and deploy this technology, making sure that we're using it for good and not creating unintended consequences that could harm individuals or society as a whole.
Well said. So to wrap up, what are some of the key takeaways our listeners should remember about 4D printing?
All right, so first, 4D printing is more than just a fancy name for 3D printing. It's about adding the dimension of time using smart materials to create objects that can transform and adapt to their environment.
Okay.
The applications are vast and varied, ranging from self-healing concrete and shape-shifting robots to personalized medical devices and clothing that adapts to your body's needs.
Wow.
And while 4D printing is still an emerging technology, it has the potential to revolutionize numerous industries and change the way we live, work, and interact with the world around us.
Right.
There are challenges to overcome, such as scalability cost and the need for more sophisticated materials and printing techniques.
Yeah.
And ethical considerations are paramount as we need to ensure that 4D printing is used responsibly and benefits society as a whole.
Those are all excellent points to remember.
Yeah.
But beyond the technical details and potential applications, I think the most important takeaway is this. 4D printing is a reminder that the future is not something that simply happens to us. It's something we create.
I completely agree. It challenges us to think beyond the limitations of traditional manufacturing and to imagine a world where objects are no longer static, but dynamic and responsive, capable of evolving and adapting to meet our ever-changing needs.
Exactly. It's about empowering people to solve problems in new and innovative ways. And that brings us to our final thought-provoking question for our listener.
Oh, I like it.
If you had the power to create anything using 4D printing, what would it be? What problem would it solve? How would it make the world a better place? Let your imagination run wild and share your ideas with us on social media using the hashtag 4DDreamBig. We can't wait to see what you come up with.
That's a fantastic challenge. And remember, even though 4D printing is still in its early stages, the possibilities are truly limitless.
Well said. And on that note, we've reached the end of our deep dive into the fascinating world of 4D printing.
It's been a really enlightening journey.
I agree. Thanks for joining us on the deep dive. We'll be back soon with another fascinating topic to explore, so be sure to subscribe and stay tuned.
Until next time, keep those minds curious and those imaginations soaring.